Hello and welcome wherever you are. I am Jakub Bijack, Professor of Statistical Demography at the University of Southampton, and it's my great pleasure to introduce the online materials for a short course, Agent-Based Modeling for Social Research. In this course, our research team would like to share a novel approach for building, validating and analyzing agent-based simulation models, which we developed as a part of a 4-year program on Bayesian agent-based population studies funded by the European Research Council. In this course, we focus on applications in social sciences, but the approach is interdisciplinary and involves 5 different ingredients. The first, obvious one, is an agent-based model, a computer simulation of processes involving what we call agents. And these agents are conscious beings who are capable of making decisions, taking actions, and interacting with one another and with the environment. These agents can be people, but also groups or institutions. The second ingredient is a programming language and environment. Some modelers prefer using general-purpose languages, which are more flexible but require more experience with programming. Others suggest using domain-specific languages, which have simple syntax but are largely limited to applications in a specific domain. In this course, we discuss the pros and cons of both approaches and also examine the best practice in documenting the model construction. The third ingredient involves data. In social applications, the data are inevitably patchy, and it will come in many guises: qualitative, quantitative, micro, macro, describing processes or contextual, and so on. It is a truism to say that a modeler needs to know what the data actually measure. Besides, as we discuss further in the course, we need to examine the different quality aspects of the data to know the limits. The fourth ingredient is linked to decisions. If the agent's behavior is to be realistic, their decisions need to be plausible. Here, we show how advances in cognitive and experimental psychology can help us build models which are more closely aligned to actual human behavior. The final, fifth ingredient is an analytical framework to put everything together. In this course, we demonstrate methods of Bayesian statistics and especially the so-called uncertainty quantification to analyze and calibrate agent-based models. This approach also helps bring all the other ingredients together. The basic idea is to build a statistical model of the agent-based model or simulation, which is called an emulator or a meta-model, and to analyze its properties. Here we show a few examples of how to do it in practice. So, welcome to this course. I hope you'll enjoy it, and I also hope you'll find the contents inspiring for your own work on agent-based models of social reality.